In this video, I will go over how to use the formulas for cost classifications from the basic concepts lecture notes by illustrating with an example. And the example comes from the lecture notes. I'll actually have the lecture notes pulled up at the same time here. If we can get them pulled up. Here they are. So we have our example right here. You can see that. And then here are the questions that we were asking. I guess before we get into the questions, let's specify which formulas from the notes you will need to answer these questions. And you need these two, the two boxed formulas in the lecture notes. The first one tells how much of the total costs that the company has are assigned to cost object I using weight vector j. So the first subscript on the v represents which vector, and the second subscript represents which cost object. And that turns out to be really important because if you transpose the I and the j and you get it mixed up in your mind, you will get the questions wrong. The second formula gives us what the proportion of the total costs that are assigned to cost object I using weight vector j is. So it's just the costs assigned to cost object I using weight vector j in the numerator divided by the total costs in the denominator. So here's our example. We see there are three costs: total variable, total fixed, total mixed, 1,000, 1,500, and 3,200. We have three cost objects: customer 1, customer 2, customer 3. These are the three cost objects that we desire cost information about. We want to know as a company, how much does it cost us to serve customer 1 and customer 2 and customer 3. For each customer, we have two possible ways to assign the costs in C to that customer. So for customer 1, we have big V sub 1, which consists of two possible vectors: V sub 1, 1, V sub 2, 1. For customer 2, we have big V sub 2, which consists of two possible vectors: little v sub 1, 2, little v sub 2, 2, and so forth. I've written the vectors here. For example, this is the customer 1. The first row is the customer 1, two possible vectors. Either customer 1 gets 1/3 of the total variable costs, 3/8 of the total fixed cost, or 4/5 and 4/5 of the total mixed cost. Or if we don't want to use that way to assign, then the customer 1 would get 1/4 of the total variable cost, 4/9 of the total fixed cost, and 4/7 of the total mixed cost. And for customer 2 is the second row, and customer 3 would be the third row. So there are two possible weight vectors for each customer in this particular problem. The first question, go to the lecture notes, is what is v sub 22 dot c? That's the dot product between vector little v sub 22 and the set of costs c, which is a vector: 1,000, 1,500, 3,200. In words, we're asking how much cost is assigned to customer 2 using vector number 2. So if we use our formula, use our boxed formula up here. K goes from 1 to n. N is the number of costs. In this example, there are 3 of them, so n equals 3. And we just multiply the weights in that vector times their respective costs and sum them up. So alpha sub 22 in k equals 1, put 1 in, times little c sub 1, plus, now put k equals 2 in, plus, now put k equals 3 in. What's this? That, again, the first subscript tells you which vector. Second subscript, which cost object. Third subscript, which element in that vector. So these alphas, these are the weights. We know we're the second vector, second cost object. So we're right here. And the 1 right there, the last subscript, tells you which weight, which element, the first one, 1/2. So 1/2 times little c sub 1 is the first cost. $1,000. I want to erase these things that I mark, or else it will get a little messy if I continue through this problem. Plus alpha sub 2, 2. Again, second vector, second cost object, second weight, 3/10, times c sub 2, the second cost, which was the fixed cost, which I believe were 1,500. If you go look up there again, check this right here, right? And then finally, alpha sub 223, second vector, second cost object, third element. So this is the cost that will be assigned to customer 2 using weight vector 2 right here. We just multiply and add, and in the lecture notes I believe you get 1,800, and we can go see what you get. 1,864.29. That's pretty straightforward. $1,864.29 are assigned to cost object to customer 2 using weight vector 2. The second question is, under which weighting scheme is customer 1 the most costly to serve? So here's customer 1 row, the first row. Here we have we can either use weight vector 1 or weight vector 2. Under which weighting scheme is customer 1 most costly to serve? All we have to do is calculate how much cost is assigned to customer 1 using weight vector 1. How much cost is assigned to customer 1 using weight vector 2, and compare the numbers and see which weighting scheme makes it to where customer 1 is the most costly to serve. Calculate this. Calculate this. If you do that, you do it the same way as we did up here, and you're going to find that this number is bigger than this number. So under weighting scheme 1, customer 1 is most costly to serve. Is more costly to serve. Yeah. And then for the third question, for each weighting scheme, list the customers in order of decreasing costliness. Okay. So for weighting scheme 1, which of these customers is most costly to serve? So we're going to compare these three. We're going to calculate V11.C, V12.C, V13.C, and see under weighting scheme 1, which customer is the most costly to serve? Customer 1, customer 2, or customer 3? And if you calculate these, you're going to get numbers for these three things, and you're going to find this holds. So in order of decreasing costliness, this is the first most costly. This is the second most costly, customer 2. It's the third most costly. That's what you'll find. For weighting scheme 2, we go back and we calculate these three, V21.C, V22.C, V23.C, and see which customer is the most costly to serve if we use weighting scheme 2. So if you do that, you're going to calculate V21.C, V22.C, and V23.C. I believe you find again this holds. So customer 1 is the most costly to serve, customer 2 is the second most costly to serve, and customer 3 is the least costly to serve using weighting scheme 2. What about question 4? What proportion of total cost is assigned to customer 1 under weighting scheme 2? Under weighting scheme 2, customer 1 gets this cost, whatever that number was, right? First subscript tells which weighting scheme or which vector. Second subscript tells which customer, which cost object. So customer 1 under weighting scheme 2 gets this much cost. Let's go ahead and calculate that. We know K goes from 1 to 3. And we're doing alpha sub ji, j is 2, I is 1, k, times c sub k. So alpha 2, 1, 1, c1, plus alpha sub 2, 1, 2, c2, plus alpha sub 2, 1, 3, c3, alpha sub 2, 1, 1. So we're in the second vector, first cost object, right here, 1/4. 1/4 of the total variable costs are assigned to customer 1 using weighting scheme 2. 4/9 of the total fixed costs are assigned to customer 1 using weighting scheme 2. And the total fixed costs were 1,500. And then finally, 4/7 of the total mixed costs are assigned to customer 1 if we use weighting scheme 2. And the total mixed costs were 3,200. So if we calculate all this, we will end up, and I have to go and calculate it real quickly. You will get you end up getting $2,745.24. $2,745.24. That's the cost assigned to customer 1 using weighting scheme 2. But the question is, what proportion of the total costs are assigned to customer 1 using weighting scheme 2? To answer that question, we have to calculate proportion to 1, which is just cost assigned to customer 1 using weighting scheme 2 divided by the total costs, or 22,745.24 divided by the total costs. Total costs are 1,000 plus 1,500 plus 3,200. So the total costs are 5,700. And if you do this ratio here, I believe you end up getting 48%, or 0.48. So 48% of the total $5,700 in costs are assigned to customer 1 if we use weighting scheme 2. And that means the remaining 52% of the total costs are assigned to customers 2 and 3 using left over. Now, for the questions for you to ponder, the first one we had was, go and look here in the lecture notes. What is this right here? This first question right here is just testing your knowledge of the notation. Testing if you know what the subscripts mean. They're asking for, I'll go ahead and write it like this. Actually, maybe I wrote it wrong. I1, so it's alpha sub j I k, I goes from 1 to 3. It's always written in, always j is the first subscript, I is the second, and k is the third, always. J represents which vector, I represents which cost object, k represents which, in that vector, in that jth vector, which element. That's what k is. So what's this for, there are two questions actually. When j equals 1, k equals 1, and when j equals 2, k equals 2. That's one question. Another question is, what's the sum whenever j equals 2, k equals 2? This is just testing your analytical, critical thinking ability, and it improves it, I believe. So I don't think it's a bad thing to do this exercise, even though it really doesn't have anything to do directly with cost accounting. It's just a pure mathematical exercise. And nonetheless, I think it helps. So for the first one, we want to, I goes from 1 to 3, and we're fixing j at 1, I is I, k is 1. So we want to calculate. So that's just alpha 1, now put 1 in for I. So alpha 1, 1, 1, plus alpha 1, I'll put 2 in for I, 1, 2, 1, J and K are fixed at 1 and 1, respectively. It's just I is going from 1 to 3. So we're calculating this. Again, first alpha 1, 1, 1. First vector, that's the first subscript. The second subscript tells which cost object, first cost object. And then in that vector, the first element. So the first vector, first cost object, first element. Here's first vector, first cost object, first element, that's here. First vector, second cost object, first element, that's here. First vector, third cost object, first element, that's here. So alpha 1, 1, 1, alpha 1, 2, 1, and alpha 1, 3, 1, right here. 1/3 plus 3/5 plus 1/15. And you get some answer. I don't know. I won't calculate it. I'll leave that to you. Then the second question is, we're going to fix, or we're going to let I go from 1 to 3. We're going to fix J and K at 2, respectively. This second question right here. So we're going to have 2, 1, 2 plus alpha 2, 2, 2 plus alpha 2, 3, 2. Alpha 2, 1, 2. Again, second vector, first cost object, second element. Second vector, first cost object, second element. That's 2, 1, 2. 2, 2, 2. Second vector, second cost object, second element. 2, 3, 2. Second vector, third cost object, second element. And I've forgotten. 4/9 plus 3/10 plus 23/90. And you get some number. For the second question, let's go look here. Excuse me. Which customer is costliest in terms of variable costs? This is actually pretty easy to answer. You actually have, this question isn't quite fair. It could lead to it not having an answer, and you'll see why. Really, the better question is, which customer is costliest in terms of variable costs if we use weighting scheme 1? And then ask the same question, but if we use weighting scheme 2. But the question asked as is could possibly not have an answer. If we use weighting scheme 1, and we're trying to figure out which customer is the costliest in terms of just variable costs. Looks like I've deleted some things here. Get this back. What was this, 1/10? Can't remember what that was. Is that 1/10? Sorry, guys. I'm gonna have to go back. Oh, it was 1/15. All right, 1/15. 15th, 4/9. There we go. Which customer is costliest in terms of variable costs? Variable costs are the first costs right here. They're in the first position. So let's just look for weighting scheme 1, just for these. This is weighting scheme 1, and this represents weighting scheme 2. Pardon my messy handwriting. So under weighting scheme 1, which customer is costliest in terms of variable costs? Just look at the first weight. Looks like customer 2 would be the costliest because customer 2 would get 3/5 of the variable costs. Customer 1 would get 1/3 and customer 3 would get 1/15. 3/5 is bigger than 1/3 and 1/15. Customer 2 would get more of the variable costs and therefore would be the most costly in terms of variable costs if we use weighting scheme 1. But what about if we use weighting scheme 2? Is customer 2 still the most costly? Yes, because 1/2 is bigger than 1/4 and 1/4. So it just turns out that customer 2 is the most costly in terms of variable costs if we use, no matter which weighting scheme we use. But if I had it set up to where under weighting scheme 1, customer 2 is the most costly in terms of variable costs, but under weighting scheme 2, customer 1 is the most costly in terms of variable costs. In other words, if I had just switched these, just be like 1/2 and 1/4, then answering the question which customer is most costly in terms of variable cost doesn't have an answer, right? Because it depends on the weighting scheme. So if it was on an exam, I could say, that possible answers could be customer 1, customer 2, customer 3, and the third one would be cannot tell, or the fourth one would be cannot tell from the given information. Or depends would be the, I guess, the fourth choice. If we go down here to the next question, question 3, it asks which customer, go to the lecture notes here, which customer is costliest in terms of the fixed costs? It's the same sort of thing. Here, the fixed costs are the second element. If you look here, it's the second part. So again, under weighting scheme 1, which customer is the costliest? Which of these weights is the biggest? Customer 1 would get 3/8 of the fixed costs. Customer 2 would get 1/3. Customer 3 would get 7/24. 3/9 is equal to 1/3. So 3/8 has got to be bigger than 1/3. So 3/8 is bigger than this. So customer 1 is more costly than customer 2 in terms of fixed costs. What about customer 3? 7/24 must be less than 8/24. 8/24 is 1/3. So 7/24 is less than 1/3. And we know 3/8 is bigger than 1/3. So customer 1 is the most costly in terms of fixed costs under weighting scheme 1. What about under weighting scheme 2? Customer 1 would get 4/9, customer 2 would get 3/10, and customer 3 would get 23/90. 3/9 again is 1/3. So 4/9 has got to be bigger than 3/10. And then we know that 30/90 is 1/3. So 23/90 has got to be less than 1/3. 3/10 is also less than 1/3, right? Because 3/9 is 1/3. 3/10 is 0.3. 23/90 is something less than 0.3, I believe. But it doesn't really matter because we know that 4/9 is bigger than both of those. So no matter which weighting scheme we use, customer 1 is the most costly in terms of fixed costs. And then the final question is a little trickier, or it seems a little trickier on the surface. Some companies like to take shortcuts and just assign an equal percentage of costs for each category to each customer. That's the simplest way. For each customer, for the 3 customers, each one gets 1/3 of all the costs. And the question is, if we do that, if we take that shortcut, and the true weighting scheme is the second weighting scheme for each customer, how far do the true mixed cost for customers 1, 2, and 3 differ from the ones assigned using an equal weighting scheme? So if we use an equal weighting scheme would be like this. For customer 1, what portion of mixed cost would customer 1 get? He would get 1/3 of the mixed cost, right? The first weight is the weight that tells how much of the variable goes to customer 1. The second one obviously is the one that tells how much of the proportion of the fixed cost goes, and the third of the mixed cost. So if we use the equal weighting scheme, then customer 1, if we just do this equal weighting scheme versus true weighting scheme. For customer 1, I guess we can put a column for customer as well. So for customer 1, equal weighting scheme would give customer 1 1/3 times 3,200, or let's see, 1 divided by 3 times 3,200 equals 1,067 approximately. If we use the true weighting scheme for customer 1, how much of the mixed cost would they get? And what were we saying? We said that the true weighting scheme, if we look here, the true weighting scheme is a second weighting scheme for each customer. That's the true one. Suppose that's really what it costs us for each customer. It's using this. So for customer 1, we'd be using this 1/4, 4/9, 4/7. 1/4, 4/9, 4/7. That's the true weighting scheme. So for the mixed cost, customer 1 should get, we gave them 1/3 of it, but they should get 4/7 times 3,200. And if you do that, you'll get 4/7 divided by 3,200. I mean, sorry, 4/7 times 3,200. 1,829. And then the question though is, how far did the true mixed costs differ from the ones assigned using the equal weighting scheme? So what's the difference between these numbers? This 1,829 and 1,067. If we use an equal weighting scheme, if we take a shortcut, we're going to undercost customer one. We're going to say that they cost us 1,067 in terms of mixed cost, when they really cost us 1,829. That's the idea. So the difference here, I don't have a column for difference, but the difference between these two numbers would be, where can I do this? 1,829 minus 1,067. We would undercost them. 762 undercost customer one. Now I'm going to erase that. And that's bad, right? We don't want to undercost. We don't want to say they cost less than what they really cost us, because then the price we charge to that customer won't be reflected, or won't reflect that, and we will probably lose money on that customer. All right. What about customer two? Customer two, if we use the equal weighting scheme, customer two again is going to get 1/3 times 3,200, 1,067. Customer three is also going to get 1,067 if we use an equal weighting scheme. Of the mixed cost, each one gets 1/3, right? But for customer two, what's the true weighting scheme for customer two? What should the customer of two have gotten? If we go back up, the true weighting scheme for customer two, if we're using the weighting scheme two, is 1/2, 3/10, 2/7. 1/2, 3/10, 2/7. So 2/7 times 3,200 is what customer two would get. That's what they should get. Not what they got, but what they should get. That's the true. 914 bucks. So using the true weighting scheme for customer two, they should get 914, but we gave them 1,067. We overcost that customer. We're saying it cost us 1,067 in mixed costs for that customer, but really it only cost us 914. That's also bad. Overcosting is bad as well, because we're going to charge too high of a price for this customer. We might lose that customer, and they'll go to other customers, other potential customers, and tell them that we charge a high price, and the customers won't go with us. They'll go with another company. And then for customer three, you can see the idea. What's the true weighting scheme? If we're using weighting scheme two, it's 1/4, 23 over 90, and 1/7. So we should give 1/7 of the mixed cost to customer three. But we should only give them 457, but we end up giving them 1,067. So we really overcost customer three. We might lose customers two and three, and then not be making money on customer one because we're charging them too low of a price because we undercost them. So you can see how this could be a problem.